Okay, now we're going to draw some parallel lines and transversals, and then we're going to have a look at the angles that come with those. Okay, so now we're looking at, now what happens when you got these, you put these two together, you got the parallel lines, and then you cut across them. Well, let's draw one. Okay. Okay. Now let's put some labels on this so that we can actually start to talk about this thing. I'll call this one AB, this one CD, and this one PQ. Okay, now, what's the normal way? Like you can see I've tried to draw these parallel, but we usually label them in some way to indicate that they're parallel. How do we do that?
Yep. Like arrows.
Good. So somewhere along there, you put an arrow there and an arrow here. Okay. And that tells us, right, these are never going to meet. So here I can say A, B, and C, D are parallel lines. Or they're just parallel. Okay. But that takes forever to write, and you're going to be saying these are parallel a lot. So instead, we say this, A, B, and then you literally put two parallel lines, right? You say that. So these two mean the same thing. A, B, and C, D are parallel. This is our notation for A, B, and C, D are parallel. Okay? So what's PQ?
Transversal.
PQ is the transversal.
So,
Okay, yes?
Is that IE next to the AB?
Yeah, yeah. As in, that is Latin. It's, anyway, just like EG is, anyway. It is Latin. Okay. Now what kinds of angles have we got here, and what patterns can we take advantage of, right? Well, here's what I want to suggest. Remember when I was talking about the planets before, right? And I was like, no one's ever been to that planet. How do they know anything about what that planet is like? Well, we can do a similar thing here. Suppose, I should have brought it with me, okay? I had a big giant protractor. I have actually a big yellow one in my staff room. And I measured this angle here. Now, just if you had to guess, what does it look like? Like, what's a reasonable number for that in degrees?
Like less than.
no, it's about 100.
It's between, what? Oh, by the way, we have language for this. What kind of angle is it in terms of size? It's obtuse, right? So it's between 90 and 180. How about 120? That looks about right, doesn't it? Okay. Now suppose it does seem legit. If I measured that with my protractor, right? Here's the great thing here. I've measured one angle, but there are 1, 2, 3, 4, 5, 6, 7, 8 angles here, and now I know the size of all of them without measuring any more. How do I do that? How do I just measure one angle, and then I can know the rest? Ali, can you tell me one other angle? Actually, maybe I should put some more labels on here. I'll call that X and Y. Can you name an angle for me and tell me what its size is? Can anyone tell me, for instance, what's PXB? Angle PXB, what's that equal to?
90 degrees.
Think about it. It's angles along a straight line, right? Angles along a straight line. Angles on a straight line, they add up to, think back. They add up to, on a straight line, they add up to 180. So I actually want 60 over here, don't I?
So, but does it
Okay.
with that?
And then X.
Yeah?
X is 60 because it's vertically opposite. And then
You mean AXY?
AXY.
Yeah, okay, so that's 60 degrees there, because
Yeah, and then,
it's vertically opposite. You do the same thing
Yeah,
here.
it's 120.
Okay?
Yeah,
And I can keep going. I can go down to this one in a second, okay? But how do we do it? Yeah.
Question, is it BXQ or is it BXY?
Well, because PQ is a straight line, right? And X and Y are on that straight line. Angle BXY, okay? It's not just equal to, it is the same, whoops, as, what did you look at, BXQ?
Yeah.
They are actually the same angle, okay? So the difference is one of the arms goes longer, but it's the angle in there that matters.
Okay, so if you were to write it, would you write it with a Y or with a Q, or it doesn't matter?
Doesn't matter. Okay, now in order to get from here, like, what did we use to do that? We knew angles on a straight line, and we knew the vertically opposite there, okay? But to get from all of these angles, these four, down to these four, we need a few more pieces. And a few more shapes and patterns to recognize, okay? So, underneath where you've drawn this diagram, we're going to draw 3 more, okay? And they'll look like this, right? Here's my first one. Okay. Now, when you've got that F-looking shape, okay, and you're looking at the two angles that are nestled up in the corners, okay, these two angles, they match together. They're related to each other in an important way. They have a name, starts with C. Does anyone remember what they are? Very close.
Corresponding.
It's corresponding. Okay, we're going to get to cointerior in a second, but these are called corresponding angles. Okay? Now, when you've got corresponding angles between parallel lines, what can we say about them? What can we say about them? What do they look like?
F shape.
Like, I mean, in terms of the size of each angle, how do they look in comparison to each other?
What does it say on the diagram on the right where it says BXY is the...
Same as BXQ.
Oh.
Okay. How do they look? They look the same, don't they? They look the same, and they are. Okay. Corresponding angles on, that's an N, on parallel lines are equal. Okay? So I can call this A degrees, and if I know it's A degrees, I know the other one's A degrees as well. Okay, now that was the F shape, right? Does anyone remember there are other shapes as well that help us recognize patterns?
C and S.
C and, whoa,
Z.
it's Z, isn't it? Let's do this, actually I'll do the Z first. I'll do the Z. Because that's not an S, right? It's the, okay. These two angles here, if I've got parallel lines, okay, what do I call these ones? Starts with an A.
Alternate.
Alternate angles. Okay? Not to be confused with alternative angles. Alternative is a musical style. Alternate is about angles, okay? What's the relationship? Again, what does it look like how do they compare to each other?
The angles are the same.
They look the same, don't they? Okay? Alternate angles are, on parallel lines, are also equal. Okay? So, I call those angles A. Let's call this B. B degrees, B degrees. Okay? So there's your F, which gives you corresponding angles. There's your Z, which gives you alternate angles. What's the last one? It's the C, isn't it? Now, be careful. I'm going to draw two different C's, okay? And you'll see why in a second. Amy, what's your
Isn't
question?
it F-U-N and it spells fun?
No.
How do you make a U out of this?
No, you turn
That
the
is
Z
an
around and then the C is actually a U.
You can.
Oh, I see what you mean. Yeah, okay.
And then you make it like
Oh, yeah, you could do fun if you like. You can draw that.
Huh.
That's how I
Alright, I'm going to do this down here. Now, probably most of you will draw your C like that. If you made it a U, it'd be, that way, okay? But next to this, I want to draw another C that looks a little bit different, okay? I want to put both of them together and compare them, right? So here's the C I want to draw this time. Here. No, hold on. Now, you got to be careful about how you draw this one, okay? Okay, now do you agree that basically they're both the same shape? Yeah, basically, okay? Now, which are the angles we're interested in? They're the ones in here, and here, okay? Where are they on this second diagram, the second C?
In the same place.
They're in the same spot, aren't they? These corners in here.
They're just
Okay.
different.
Now, look at it carefully, right? Corresponding angles, equal. Alternate angles, also equal. Now, when you look at this one, it's tempting to think they look quite close to each other. But when you look at this other one, it's kind of more obvious, isn't it?
More sharper.
These angles are not the same. They're very not the same. This one's blunt, which is obtuse. This one's sharp, which is acute. So how are they related to each other?
They equal to 180.
That's okay, wait, hold on. They equal to 180. They add up to 180 is probably a more specific, which is what you were saying. I think that's what you were thinking.
Yeah.
But it's a more specific way to say it. Okay. Now what do we call these? These are co-interior angles. Why are they called co-interior?
Because they're inside.
Yeah, and they're inside, and both of them are inside. That's what the co means. Right? Co-interior angles on parallel lines. Now we have a word to describe when two things add up to 180 degrees. Long, awkward word, hard to spell. Starts with an S.
Guarantee the perfect line.
Supplementary. Supplementary.
We should just put a sign at the door. Hey, we'll save us time.
German line is going here.
Okay. What were we saying? What was the word? S. Supplementary.
Is he moving the whole week?
No, never.
Okay. Which I think it'd be nice if you put it in brackets after this. They add to
Oh, yeah.
180 degrees. Okay, now hold on a second. We had A and A, B and B. What am I going to put in here? I can't say C and C because they're equal, right? But they're not equal. So how do I say it? If I call, for instance, if I call one C, what must the other one be?
D. A rhyme.
Now it does. I could call it D, right? But actually, like C and D are related to each other in an important way, namely this: they add up to 180 degrees, right? So if you say C degrees plus some other thing, this is the other angle I'm trying to work out, it's equal to 180. That's the supplementary. Does that make sense?
Yep.
So if I want to know what this thing is on its own, how do I rearrange it? I've got to subtract C from both sides, don't I? Can you see what would happen if I subtract C from both sides? I'll get whatever that angle is, right, is equal to 180 degrees minus C degrees. See how I subtracted C from both sides?
Yep.
So that's what I'm going to call this angle down here. I'm going to call it 180 minus C degrees. Okay? C, 180 minus C. That's what makes them supplementary. Okay. Now that we know that, can we work out these angles in here? For instance, what's this one equal to? You could use any of these. You could say it could be corresponding to something, alternate to something, or conterior to something. Let's say corresponding. What's an angle that's corresponding to this angle down here? Can you name it? What angle corresponds to PYD? Look at the diagram and what shape you're looking for.
120.
No.
Can you name it? Can you name which angle should say PYD is corresponding to? Can you name one? I think it's PXB. Can you see it? If I draw like this, can you see there's an F there? Can you see that?
Then what
It's just
about
upside down.
What about BXY?
BXY. Okay, yep. How are they related? These two angles. They're not corresponding, are they?
Co-interior.
They're co-interior. So, in the first place, I said it was corresponding to this angle up here, which means it's equal.
Sorry.
Does it still make sense? Are the co-interior angles supplementary? They are, aren't they? And you can keep going. You can go, that's 60, that's 120, that's 120 as well. Okay?